Okay, our topic for today is factorizing expressions. Factorizing is a very, very important concept that we need in order to do a lot of the other things that we do from here on in mathematics. Factorizing, or if we were in America, we'd call it factoring. Factorizing is just the reverse of a process you already know how to do, which is called expanding brackets. So if we had 2x plus 5, 3 times the quantity 2x plus 5, if we were to expand that, what do? In order to expand that, we take the outside item and we multiply it times each of the inside things. And we would get 3 times 2x is 6x, plus 3 times 5 is 15. 6x plus 15. Now if I wanted to factorize it, I would do exactly the opposite. The first step in factorizing is figuring out what the highest common factor is. Just like when we were doing fractions and getting denominators the same and those sorts of ideas, the highest common factor is the biggest number that will divide evenly into both of our terms. So we have two terms here, 6x and 15. What's the highest thing that will divide evenly into both of those? Well, it's 3. So we say 3, and then we say 6x divided by 3 gives me 2x, plus, and 15 divided by 3 gives me 5. So this process is called expanding, and this process is called factorizing. Now we're going to do a little bit more detail on that, but you might notice that these two things are the same. And so when you're doing factorizing, one of the ways that you can check whether you have done it right or approximately done it right is to re-expand what you've done. You expand these brackets and you should get back to exactly what you started with. Now we're going to erase this example and we're going to do some more examples. The key, of course, to factorizing, the first key is to find the highest common factor. So, highest common factor, or HCF, we use some examples. HCF. Let's say that we had 15x. You will start with an easier one than that. Let's start with 20 and 35. 20 and 35. Now, what is the biggest number that will divide evenly into both of those? Well, the biggest number, the highest common factor of those two is 5. There's no number bigger than that will divide evenly. Now let's go back to the 15x example. 15x, 20y. And when we have both numbers and pronumerals, we sort of treat them a little bit separately, and then we'll put them back together in the end. So the first question is, what's the biggest number that will divide evenly into both 15 and 20? Well, again, that number is going to be 5. And then after that, we look at our pronumerals. Here we have x and we have y. There's nothing related between those two. There's nothing more that we can do. So we're done. 5 is our answer. Now let's try another example. Let's say we had 12x and 18xy. Again, start with our numbers. What's the biggest number that will divide evenly into both? Well, we could start with 2, but there's a bigger number. How about 3? Sure, 12 will divide by 3, 18 will divide by 3. There's still a larger number, 6. 12 will divide by 6, 18 will divide by 6. That's the biggest number we can use. We'll take 6. Then we look at our pronumerals. Over here we have x, over here we have x and y. So what's in common? What's the biggest thing in common? X. So with these two expressions, the largest common factor, the highest common factor is 6x. One more example. Let's say we had 12x and 15x squared. Well, starting with the numbers, what's the largest number that will divide evenly into both 12 and 15? Largest number would be 3. Now, what about the pronumerals? There's an x here, x squared here. Both of those will divide evenly by x. And that's as much as we can get out of those, so that's done. Okay? That's the first step to being able to factorize. Now, let's expand this. Probably should use a different word. Let's move this forward to the actual process of factorizing. So we use some examples. I've erased it, but keep in mind our first question is going to be, what's the highest common factor? So let's start with 6x plus 15. My first question is, what's the highest common factor? Well, the biggest number that I can take out of both 6 and 15 is what? 3. So we're going to start with 3. Is there something we can take out of the pronumerals in both? No, there's no pronumeral here, so we can't do anything more. So we put a bracket, then we take 6x and we divide it by 3. Now you'll remember from when we did that, we divide the numbers and we do something different with the pronumerals, but there's no pronumeral out there. So all we have to do is say 6 divided by 3 is 2, and then put our x back. Plus 15 divided by 3 is 5. And we're done. Now remember, we could expand this just to make sure that we did it right. 3 times 2x, that's 6x. 3 times 5 is 15. So we've probably done it right. Let's try another one. Let's try 12a plus 18ab. Start with the numbers. What's the biggest number that will come out evenly of 12 and 18? We've done that already. It's 6. Now what about the pronumerals? Is there something in common? Sure, there's an a. So we take out the a, and what we're doing then is we're dividing by 6a. So 12a divided by 6a, the 12 divided by 6, do the numbers first, divide the numbers, we get 2, and then we have a divided by a, which is 1, that means it's gone, it cancels, plus 18 divided by 6 is 3. And we have AB divided by A times B divided by A, that means the A's cancel, and we're just left with B. Again, you can expand it to check your math. 6A times 2, that's 12A. 6A times 3B, multiply the numbers, collect the letters. 6 times 3 is 18, A times B, AB, and we're good. Okay? Next example. 21, let's draw a line here to keep these separated. 21x minus 14y. Now, what's our highest common factor? Always the first question when factorizing. What is the highest common factor? 21, 14, biggest number that will divide evenly into both of those is 7. Excuse me, I shouldn't have put the bracket there yet. Should have asked the question, what about the pronumerals? Well, in this case, there's nothing I can do. They're different pronumerals. They have nothing in common. So, 21x divided by 7. 21 divided by 7 is 3. The x remains. Minus, because it was minus here. 14 divided by 7 is 2. And the y is left. And there we have it. Now, you can take a break if you want and expand this. I'm not going to do it this time, but if you expand that, you'll find out that it works back out to that. 2 more examples. Negative 10a minus 20. Now, what's the biggest number that will divide evenly into this and this? Your first reaction might be 10, and you wouldn't be wrong about that. 10. However, there's also something else in common between these two numbers, and that is the minus. So I can actually divide the minus out as well. And when I do that, there's no pronumeral that's in common, so I can't divide out a pronumeral. But when I divide this by minus 10, I'm left with just a, because the minus divides itself out. Minus divided by minus is a plus, so I'm left with positive a. Now, remember the minus goes with the number after it, so when I divide out this minus, then I'm left with a plus, and I have negative 20 divided by negative 10 is positive 2. Again, if we want to expand this, and we will do this one, just to check, minus 10 times a, minus 10a, minus 10 times 2, minus 20. And we've done well. One more example. X squared plus 4x. Now this time, this is slightly different because we don't actually have any numbers in common. We don't have any numbers that we can divide out. So the highest common factor doesn't actually involve a number. What does it involve? Well, there's x squared here, and there's x here, so we can divide out factor x. That is our highest common factor. X squared divided by x is x. If that seemed a little confusing to you, remember that x times x is x squared, if we re-expanded it. Plus 4x divided by x. If I pull that out, I divide that out, what's left? 4. And if you want to re-expand it to check, x times x squared, 4 times x, 4x. And that is factorizing expressions.